Once again, this is Hams Consulting and Inspection. Today will be my first video uh, to the new year 2025. It is the fourth day of the year. So this is my first documentation video. This is for informational purposes only. So the one that I'm gonna document today is regarding special inspection for intumescent fire-resistant materials. So it's an intumescent paint coating. This kind of material is the protection of the skeletal member of the building, houses, if ever it was required or specified by the engineer, the designer, the architect. So this kind of stuff is it will maintain the structural steel member of a particular facility during fire condition. So it's a sustaining material that will protect the structural steel, like beams, trusses, and columns, so that during fire condition, in a certain amount of time, it will hold the structure before meltdown and collapse. So there is time for people to egress the facility before certain collapse. So let me share some uh, building codes regarding this discussion. So today, this is the application of Mastic and Intumescent fire resistant coatings. So under special inspection, this is section 1705.15, special inspection and test for mastic intumescent fire resistant coatings applied to structural elements and decks shall be in accordance with AWCI 12B. So later on, I'm gonna discuss also some uh, technical manual for this kind of stuff. So I could probably pull up the technical manual for this kind of application. So we can first, I think, click this link and see the definition. So intumescent fire resistant coatings. This is a thin film liquid mixture applied to substrate which expands into a protective foam layer to provide fire resistant protection of the substrate, which is your steel members in the building when exposed to flame or intense heat. So as I said, this is a protection during fire condition, so that in a certain amount of time it will hold uh, the the structural member before meltdown and certain collapse of facility or the location where the fire is occurring. So it was said right here, the technical manual that is applicable for this application and inspection is 12-B. Say share this technical manual. Here you go. So this is 12-A. This is applicable for fire spread fire system materials. So I have a video as different video covering this particular application. So if you could check out one of my videos on my list. But today uh, I will document, discuss a thin film intumescent fire system materials. So this is the right manual. This is technical manual 12-B. So you got the scope right here and general information. As you can see here, this is in a particular application. Uh, this covering all the necessary information for application and inspection. So you got the substrate condition also right here. Surface condition should be clean, out of grease, out of oil, and you get the temperature also. So these are all important for the application with this particular material. Site condition should be maintained also at room temperature at 50 Fahrenheit right here. And also the thickness determination and the equipment that will be used for the thickness determination. This is one of the sample of the equipment that is usually used for this kind of application. I will show later the uh, photo that I have taken as I performed this kind of inspection. And you got the frequency of the test, the method of the test. And let's see 1 year. And also, of course, as you can see here, 1 year calibration right here, interval for typical starting point of your equipment right here. So you should have at least a calibrated device for accuracy purposes. And then I'm just looking on the thickness determination right here, section 6.3.2.6. So each thickness determination should be the mean of 3 separate gauge readings within the area of half an inch diameter circular. So within that particular point, you need to uh, uh, this kind of stuff, the probe point of the tip of this device should go round at a particular point within half an inch to have the readings. So 3 readings will be average, 3 separate reading on that particular area. And then under this section 6.3.2.7, make readings at least 1 inch away from the edge. So if you're measuring the thickness of the edge, should be at least an inch, so that you're gonna have a majority of the thickness. Probably that's the purpose of that, because particularly on the edge, it's very uh, it's very difficult to maintain the thickness of this particular material. Then for the thickness, you have the tolerances right here. If you have 20% or more, it should be recorded like the specified thickness plus 20% or more, or plus 20% only. It should be recorded in the report like that. And the thickness, the minimum thickness should not be less than 80% right here. So if it happened to have a thickness measurement of, like, if the specified thickness to be acquired is 100. So the thickness measurement should not be less than 80% of that, should not be less than 80. Let's say 100 mils. So the measurement should not be lower than 80 mils. So if on particular in a certain condition, if it found it has a less than 80%, you should spray. You should ask the applicator, the technician, to spray more on that particular area of measurement. And then certain sizes of steel has particular procedure and number of thickness measurements. We got here under section 6.4.1.9, test for beams, trusses, and columns. So this is a series of thickness determination conducted in a specific pattern. So for the beams, you can see here is 9 locations around the beam. Yeah, the measurement should be end to end of a 12-inch span or 12-inch length. Each one of them should be measured 12-inch end to end of that particular beam. Columns right here. The column is, you got 12 locations to be measured. Tube and pipe columns should only have 4. The trusses should have 7. So there's also an illustration right here. So this is for the beams. As you can see, you cannot measure the top of this because it's supporting the slab, the ceiling. So we're gonna start measuring the thickness from the bottom surface of the flange, of the top flange, then the web, the top surface of the bottom flange, the tip, the bottom. So at this particular area, it's very hard to maintain the thickness because this material, as it goes thicker, it's way more. It's gonna be heavier, and for the guys to maintain that thickness, they need to wait a lot of time to cure the paint for it to stick on this area. And then this is for the W shape. Still, it's 12. That's the beam. This is the beam. This is the column now. So because it's a column, it's a foss. Everything is exposed. So the measurement will start at this point. Plunge, inner plunge surface, web, inner plunge, the tip. All the tip will be measured, and the surface of the plunges. And this is the simplest one, the tube and pipe column. So the measurement is only 4 locations. So that's within 12-inch of a span, 12-inch length, vertically end to end. So the measurement should be within a half-inch circle of the probe of the measuring device. And this is for the trusses. So the trusses should be measured like this. So 7 particular location for the trusses. Okay. So that's the technical manual. So I shared now the photos I taken during my inspection. This is the column. As you can see, this is, I believe this is just a first layer of the thickness material. So take a photo of the whole application, the whole column that we are working at during my inspection. So this is on the cellar level. And the material that has been used was identified as carboline, fireproofing coatings. And this is the equipment I use for thickness measurement. So as you can see, this is 7.7 mils, or this is thousand above inch unit or mils. It's 7.7 mils. Currently, that's the thickness that has been measured. So that's the inner side surface of the plunge. This is the web. Another web is 0.4 mils only. And the inner surface of the other side of the plunge, as you can see. So this is the probe. The probe will circle like half of an inch of that point. On that point, you're gonna circle it half of an inch area only to have the tree average reading. So I usually do 5 readings in each point like this. So usually I think it was in the manual, also in the technical manual, or uh I'm not so sure, but usually as recommended, if you have a reading like it's too high from the three other numbers values that you have, if you determined a very high and very low number of thickness reading on this particular point, I usually have 5 readings, eliminate the lowest and the highest number, and average the three closest values for you to have that thickness on each measurement. So in each side, in each face of this steel, this column. So as once again, I got 5 measurements. I usually do that. Eliminate the lowest value and the highest value, and average the three values that is close to each other. So then the other material, what they have used for this job, details, and the batch number. This is also important so that we could if there's some issues on the job regarding the material, we could identify which batch number is not conforming to the specs as they applied it and sprayed it on the column or the steel, the substrate, the beams. So this is another measurement of the outer surface of the plunge, 4.9, 9.7, 6.0 mils, 3.5, 5.5. As you can see, this is like just so thin thickness. And for this steel protection, you need to acquire at least maybe 100 mils. Later, I'm gonna show the supporting documents, the submittals for the material, and the required fire rating, the duration of the protection. So if if I could share something that I have experienced before. So one of the job that I've been going back and forth and doing this kind of inspection, the guys that are applying this kind of material are having a hard time maintaining the thickness, because for the 3 consecutive visits I have, they I could say the progress of the thickness was so low, and because the the reason is these guys are uh I could say they are not certified, they're not experienced enough, and the contractor got frustrated because I think uh as the job goes longer and longer, the more money they're gonna spend, and the owner is the owner who's spending the money is also gonna be spending a lot. So what I told them, as we could sideways for this discussion, as a recommendation, I only recommend, but it's still, I told them it's up to the engineer or the designer, the architect to approve an alternative protection like this one. So this is a shaft partition wall. This is an hour rated. This is the detail of installation for an hour rated enclosure or protection of fire enclosure. So it should be a layers 5/8 as per this detail, layer 5/8 on the other side or both other side of the stud, and 1 inch thick liner panel. No, it's like which one is this one? It's so it's a liner panel. Yeah, it's 1 inch thick, and this is 5/8 think gypsum wallboard X type X fire rated gypsum wallboard. So this is one of the details. Another detail right here. This is also an enclosure. This is a 2-hour rated installation detail. So 2 layers of 5/8 on both sides of the studs. This is an alternative. You could see this in the walls also on rated walls. Usually this is the details. Other details. So this is example of the installation. This is an enclosure for a duct. So because the duct penetrate a, a floor or a ceiling, you need to isolate that rating by building an enclosure like this. So this should be 2 layers right here and 2 layers on the inside, both side of the framing or the stud. So we can say this is a ductwork. We could also keep as an example, we like this duct is like the column that needs to be protected from fire condition, or needs to have a fire rated enclosure like this. So that's the recommendation that I have discussed with them, but still it's up to the designer of the building or the engineer or the architect to have it approved, because if they're spending too much money on the paint, on the Intumescent paint, this is one alternative that is much more simpler to install. But yeah, and much faster. Just another detail right here. Okay, going back to the main discussion. So this is the Intumescent paint, and this is the 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 material they use to clean out the grease and the oil on the substrate or the steel. This is the spray machine, and that's steering the material now for preparation. And that's the setup and the spraying activity. So as you can see, it will be sprayed layer by layer, thin sprayed like that. It will take time for it to cure. So in the submittals or the supporting documents of the material, there is a specified film thickness to acquire. So this is the wet thickness uh, application. So you don't need to exceed on the specified wet film thickness as per document as per the approved or the supporting documents material, because it will uh might fall down, or it might uh, not have the correct thickness for it to cure on a certain amount of time. I think for a required thickness, there's a particular equivalent time for it to cure for another layer to be applied. And this is the application condition. This is one of the supporting document, one of the pages for the fireproofing material, Intumescent paint. So you're gonna have 0 to 85 humidity, minimum maximum on the atmosphere or the room that you're doing it. So imagine you have 24 hours for another coating. So this is dry, 24 hours to wait for it to dry, to recoat. So it will take a long time. This is my own measuring wet film thickness for reference record. And this is the thicker condition compared to the other previous photos that I have shown. So this is how thick it's gonna be. Maybe how many layers is this? That's what's gonna look like. So when it's dry, also it will tend to be to fell like this. So on this condition, they need to spray this up, this particular point, retouch. And then this is the requirement now. This is on the drawing or the stamp of the stamp approval of the designer or the architect, engineer. So the requirement is 2-hour rating. So within 2-hour duration, it will protect the structural member of the building or house. So for that time, before the steel is totally exposed to the fire or excessive heat, before meltdown and collapse, this material will sustain it within 2 hours before the material, the columns or the steel are exposed. So that's the rating. If it's properly or correctly applied. So imagine this is the rating now. Column, upper balcony and cellar. You got 2-hour fire rating, and for that to have a 2-hour rating, this is the equivalent thickness. As you can see, this is a lot. It's gonna be a lot of thickness to uh, acquire. So as you can see, the previous photos I've shown, it only falls to 7 mils, 5.5 mils, or 6 mils only. It will take a lot of time, and it depends on the curing. As you can see, 24 hours before they got another coating. Imagine how many coatings will this gonna take? 126 mils and 150 mils. And measurement that I have shown is only like it doesn't reach up to 10 mils yet. So it's gonna be an expensive labor, a lot of waiting, and how many cans of materials gonna be used, given that it's not gonna fall down, or because as it goes thicker, it will be heavier. So it's a very difficult application, and uh, the curing, to maintain it, it is a long application. So, all right. Okay, so that's it for this inspection. And let me know if you have any question or comments on this particular inspection details. So see you in the next one. Bye for now. Mm, don't know how to stop.